So today, as a practical section, so here again I will show you one unknown salt detection. Okay. So again this is a term from the inorganic portion. So salt detection. Okay. Okay. So for this, one inorganic salt will be supplied to you. Now I am taking a salt from this bottle. This is known to me. This is a salt that is zinc nitrate. Okay. So this is a group 4 salt. Now how to treat it? So first of all, preparation of OS, original solution. Now most of the salts are basically water soluble. So first of all, taking it, I will add distilled water on this. So this is the original sample taken. Now add distilled water to this to make half of the test tube. This is OS. Now shake it well so that it makes a homogeneous solution. Okay. Now keep it reserved for the further test. Now first test, this is for anions. So test for anions. As the tests are done by wet manner, that is wet test. So we will follow the taking the OS and then the proper reagent. So in wet test, we will test for the halides, basically the chlorides, the sulphates, the nitrate, etc. These three anions are very common in your exam. So first test for chloride. Taking a very little volume of sample. Now, what is the reagent for chloride? This is silver nitrate, which is found in such colored bottle. Now adding very cautiously silver nitrate to the solution. Okay. Silver nitrate added, but the solution remains transparent. Okay. So here no conclusions will be done. So we have to reject the solution and we will move to the next experiment. Before going to the next experiment, we have to wash the test tube thoroughly so that the remaining part of the reagents will move. Next, again taking the OS. Next test for sulphate. Okay. Now what is the reagent for sulphate? That is barium chloride solution. Now adding barium chloride solution to the original solution. No PPT was found. The solution remains transparent here also. So from there, no conclusions will be done. So the two experiment, that is test for halide and test for sulphate, was rejected. There is no conclusions from that side. Now we will test for the last one, that is nitrate. Okay. So for nitrate, again the OS will be taken in a test tube. This is the OS taken. Now freshly prepared ferrous sulphate solution. Now previously it is kept here, it is the ferrous sulphate solution. I will add it here. ferrous sulphate added. Now drop by drop concentrate sulfuric acid will be added along the wall of the test tube. Now you will look at the solution portion of the test tube. Now a brownish color just appears. Now you have to wet it. Okay, I will show you the brownish color. From here it is looking transparent. A very faint brownish color. So we have to wait from till the experiments over. Okay, so I am keeping it here. Next, moving to the next test for cations. Now for cation, again the original sample will be taken, and next the group reagents. So first of all, dilute HCl. Dilute HCl is added to the solution. No PPT is here, so group 1 is absent. Next, now group 2 and group 4, these two groups required H2S gases. So here we will follow the using sulphide flakes to produce H2S gas. Okay, now in acid medium, if we use sodium sulphide, then it will produce the sulphide gas. From there we will move to the group analysis. Okay, now you can see the brown ring formed. You can see the brown ring. Now it becomes clear. Okay, can you see it? Okay. So group 1 absent. Next, we will add sodium sulphide flakes here. as it is acid medium, so sodium sulphide will produce H2S gas, which is coming out from the mouth of the test tube, but there is no PPT is there. Okay. So in this solution we will add ammonium chloride, and then ammonium hydroxide. We have jumped one group, that is group 3, that is the aluminium and iron, because as the test tube is already made with H2S, we have jumped to group 4. Okay. Now you can see a heavy white PPT here. Now when white PPT will comes, the group 4 containing cobalt, nickel, manganese and zinc, so the white PPT comes for the zinc. Now we will test further to prove it as it is zinc or not. So for this we have to dissolve the PPT. Now reduce the volume of the PPT, and we have to dissolve the PPT in dilute HCl. I am taking a very much little solution on that test tube and dissolving it by using dilute HCl. Okay, a clear solution form. Now specific reagent. Now the potassium ferrocyanide is a reagent used to test zinc, and if you add directly potassium ferrocyanide to the zinc solution, then it will gives the PPT, which is coming now. Okay. So next test I will show you the direct test with the original solution. Now look at that. This is the potassium ferrocyanide solution. As it is just yellowish, so here you can see a just the PPT is just like the bluish white, a bluish color is there, or a white but not so just look at that PPT. Okay. So this is the PPT formed. Again I will show you taking the original solution. This is the original solution and transferring it to a test tube. Okay. Now compare in between these two PPTs. This is having the same color. Okay. So this indicates that as cation it is zinc, as an anion it is nitrate. Okay. Now, what is the test responsible for this? So first of all, as we got nitrate, so first test is for nitrate. What is the formula of brown ring test? It is also one question for the Viva. Test for nitrate. So we have taken one nitrate salt, suppose NO3 minus plus H2SO4. It will produce one salt, that is a bisalt plus KHSO4. If KNO3 is taken as a sample, then KHSO4 plus HNO3. Next step is that addition of ferrous sulphate. Ferrous sulphate in presence of H2SO4 and HNO3, it will produce Fe2SO4 whole thrice, that is iron sulphate, and NO. This NO is responsible for the brown ring, which may combination with ferrous sulphate and water. This is the FeNO H2O 5 times within third bracket and then SO4. So what is the formula of the brown ring? FeNO H2O whole 5 within third bracket and then sulphate, penta aqua nitroso ferrous sulphate. This is the name of that compound. Next, what is the conformation test for zinc? So in zinc, we have got the PPT for group 4. Now, this is the precipitate of zinc sulphide. Okay. Now, when we dissolving it in HCl, then it will produce the zinc chloride. Okay. Now, zinc chloride, when treated with ferrocyanide solution, then it will produce one precipitate, that is just a displacement of this potassium ion by zinc ion, that is Zn2 FeCN whole 6 plus of KCl. This is the white or bluish white PPT. Okay. So this is the reactions involved in this particular sample. Okay. So understood everyone? So this, the ultimate conclusion is that the sample contains Zn2 plus and NO3 minus as a sample, as cations and anions.